Evening, ladies and gentlemen. My name is Gawel Solosky. I have great pleasure to present again about dark fermentation. And today I will talk about the bacteria growth. As I mentioned before, dark fermentation, as briefly talking, is special case of anaerobic digestion. And this bacterial anaerobic digestion stops not in methane production as in typical anaerobic digestion, but step before in acidogenesis where hydrogen production exists. And this means that how this bacteria grow. And the problem of industrial case is we have to predict to global scale how behave this hydrogen production. This hydrogen production is result of digestion of organic matter. This organic matter usually is sugar as composed, and for this sugar, for organic waste, usually is needed another step which is called hydrolysis. After this breaking and produced using for carbohydrates, like cellular starch and glucose, which is supposed to be earlier, this glucose is coming to bacteria. This bacteria is putting in the two cycles. During those two cycles, produces from 2 to 4 hydrogen molecules. This depends mostly from conditions, because in basic conditions, in basic pretreatment, because inoculum needs to be pretreated to stop methanogenesis, we can pretreat it by acid, base, heat, and other conditions. In most conditions, the most occurs most probable conditions which produce butyric acid due to this the lowest Gibbs energy, which show the probability. The lower Gibbs energy, the reaction is more spontaneous, so likely to occur. Only in the case of basic, some guys can more, but only slightly more of production of acetic acid. And then we can produce 4 hydrogen molecules, which then gives us the highest efficiency, 33%. But how this occurs? Because as I said, the hydrogen production occurs as cycle. This is the extraction as a man during feeding extracts some uric acid. The similar thing comes in case of bacteria, but bacteria, hydrogenic bacteria on this type, works as hydrogen. This is a circular case, periodic case, because this hydrogen is affect of metabolite. How looks the prediction? Most scientists use simple method, try to explain by exponential function. Why use bacteria for exponential function? Because the exponential function after integration gives exponent. So it's easy to operate. But it's really no. Because if you look this hydrogen production after method, we show that the production not occur continuously, but in the some flowing, one and after some period second. So it looks like periodic. So why? And we decide to check because most the trial of modeling of bacteria is coming from anaerobic digestion. In anaerobic digestion, we have such things like our anaerobic digestion modeling M1, which gives us the function of growth the as the function of kinetic demand special factors and substrate dependence. And this dependence is in the scheme of fraction fraction uh, fraction function dependence. This function dependence after integration becomes function of Arcus Tangens function. And this is the solution. Because, as you will see, documentation is step previous subsequent to methane production. So, modeling types suitable for methane after integration would be suitable for hydrogen because as the methane is derivative of acidogenesis phase. We checked and our model started working. So we started to predicting the models of hydrogen production by using growth, uh, by using Arcus tangential function. Similar case addition gave the group from Karmani from Professor Agbari from Karmani University. So we are the same. So we see that not only the simplest method is the most suitable. Sometimes that's all trouble of finding is to try to find exact function and sometimes not worry about difficulties because many functions is by by wave, by periodic function, by trigonometric functions and suitable for that. This could help us that something not works. How these all factors, and we get that some factor is responding to ratio of hydrogen sulfide to hydrogen ratio. Because we discern, however, that every time when we put sour cabbage or sugar, we have some hydrogen sulfide. And we discern that hydrogen sulfide and hydrogen occurs in special ratios, special fraction dependence. And after reviewing the web paper, the editor says, and the reviewers, that this is very interesting because no one reported. However, it feels during dark fermentation that hydrogen sulfide. So the question is why other authors don't report it. No one knows, but we checked. We published 3 papers about I published 4 papers about it, and it's in 4 cases. I put his ideas in sour cabbage, ethylene glycol, and and gelatin. In case of gelatin, it's interesting because it's only protein material. But authors more reflected to design this stage in sour cabbage when protein fraction is not so protein is not so well known, not so easily checked, was more. However, we get that this hydrogen sulfide comes from digesting of biogelatin proof because hydrogen sulfide emission is higher than we add during gelatin and similar to hydrogen sulfide sulfur in protein contain added with cabbage that is carried to rest because this fragmentation occurs the with the parallel process, which is sulfuric acid, sulfuric hydrogen sulfide emission, which helps to extract sulfur that stays during digestion of protein. Old cycle is very important because it helps to separate and protect and you would find method to refine hydrogen production during this process and then use in helping to replace the processes of conventional method. Because nowadays, hydrogen production, as I mentioned, is mostly produced by conventional method for fossil fuels that will be depleted soon. And this process, that fermentation, is a hope that we can change source of hydrogen to prolong our lifestyle. Thank you very much.